Hi, this is Professor Pyo again. Sorry for the shuffling around the different schedule, but as I promised, I would like to deliver my formal lecture from 5:30 until 6:30. And therefore, I want to utilize from now to until 5:30 to outline the reading requirement, reading for the summary of articles that I have chosen. As you will realize, these articles of mine, of course, typical example of what you have learned, that is growth accounting. Chapter 4, main theme was about economic growth accounting. And my two related articles in the past shows examples of growth accounting, particularly applied to Korean economy. So I want to just briefly share two articles. First article first. 기현아, 이리 와봐. 화면 공유를 먼저 하니 안 그러면 그 아티클을 찾아가지고 하니. 화면 PDF 파일이야. 이거 말고 이코노믹 그로스 코리아.
다른 PDF 거기에 선택하실 수 있어요.
오케이. 그 다음에 okay. The first article is about economic growth in Korea. As we have read and discussed during last several weeks, 3 weeks or 4 weeks, its perspectives on economic growth in Korea. Basically, this article covers from colonial period, 1910, to fairly recent 1999, and long-term trend and perspective. And I emailed this file to you to share. And I wanted you to read this article and briefly discuss summary. And you can put your own terms summarizing this article. What this article intends to do is to give you long-term perspective of Korean economy. So, for example, it starts with pre-colonial period. What is pre-colonial period? Pre-colonial period, knowing that Japan occupied the Korean Peninsula by 1910, we often forget this pre-colonial period existed. This pre-colonial period is very important because this pre-colonial period is kind of historical setup to become occupied, to become invaded by the Japanese imperial power. So in other words, this pre-colonial period in Korean economic history is very important period because this is the Hermit Kingdom of Lee Dynasty. He opened its port of Busan to Japan officially for the first time in 1876. Since then, Korean Peninsula became subject to hegemony power struggle among Japan, Russia, and China. until 1910, when it was formally annexed to Imperial Japan. The period between 1876 and 1910 is frequently referred to as modernization period by the Korean historians because it was the period when a series of policy reforms to transform Korea from feudal society to a modern one were introduced. Okay, so you can see in the first kind of indicator, economic indicator, population during the pre-colonial period, table 1, and table 2, agricultural production and mining sites. As you can see from 1909, 1910, there was a minor rice production increase, barley production increase, beans increase, red beans increase, and so forth. And also there are kind of mining site statistics. And metal, non-metal thing, some of the production records in early pre-colonial period. Manufacturing production, 1909. And the service sector. You can see here, for example, I want to call your attention to particularly distribution of employment by service, or, for example, you know, it's a very interesting statistics that you want to take a look at. Education statistics, particularly banking and insurance. For example, the Bank of Chosun had a branch office 12 between 1908 to 1910. Japanese commercial banks, branch office 28, outnumbering Korean commercial banks. 1908, 16, which indicates Korean government before 1910 being annexed. They had to issue a lot of national debt. And who is taking the national debt? Who is taking the national debt? That debt is taken by ultimately Japanese commercial banks. So in other words, Korean government, Lee Dynasty government, near 1907, 1910, was running government deficit. To make up the deficit, they had to issue national debt. That national debt were taken both by Japanese commercial banks, 28 of them, 16 of them. So in other words, Japanese intrusion in banking activity and investment activity started way before 1910, when Korea was formally annexed to 1910. So and so forth. So you can take a look at other statistics. And also, as you have learned, a later part, I have growth accounting results. economic growth during the colonial period and growth accounting during the colonial period has been done. And as you learned in chapter 14, chapter 4, this is a fairly long article in showing how I made up statistics, some are missing values, and then carried out growth accounting. During the colonial period growth accounting, so for example, I will show you just one example. One example is if you look at this table, average growth rate, the bottom part, from 1911 to 1945, entire 36 years of Japanese occupation, GDP has grown 4.4%. And labor input has grown to 3.1%. And capital input has grown to 'capital stock has grown total 1, 2, 3, 4. And the fourth column, 3.1%. So with these basic statistics, you can conduct growth accounting. Okay. During 1911 to 1945, growth accounting is conducted. And the summary table, you can just take a look at summary table. From, for example, 1911 to 1945, 36 years, value added growth was as much as 4.4%, labor input 3.1%, capital input 3.1%. So combined total factor input 3.2%, so that 4.4 minus 3.2 gets you total factor productivity 1.2% residual. As you learned last week, growth account. So I'm showing you by this article that you can apply growth accounting to these statistics. This is an example, for example. Okay, next, I want to move to right. Okay, this is kind of written a little bit for a few years later than the first article. It was commissioned by United Nations Industrial Development Organization, UNIDO, called, it's a UNIDO commissioned paper. UNIDO, they launched a project, research project for developing economies. And they commissioned my writing for the Republic of Korea executive summary, growth accounting result. So this is a kind of lengthy report, but it shows you the example of growth accounting. For example, record of GDP growth performance, which shows on page 3. Okay. Yeah, we can enlarge this table, right? Yeah, good enough. So from 1962 to 2000, GDP growth was very high growth, 7.89%. Labor productivity, 5.11%. Capital deepening, 8.43%. TFV growth rate, 0.43%. So, you can decompose growth performance. This is based on 1962 to 2000, reported back to UNIDO. This is the Republic of Korea's growth performance. Okay, so for you to be able to read these reports, you need a growth accounting exercise, as we did last week for chapter 4. Okay, so I gave you several examples of growth accounting result. And you can read through these cases. Index of industrial wage differences and so forth. The rest of the report deals with Korea's macroeconomic performance. Of course, documented by me for the United Nations Industrial Development Organization, UNIDO, which is based in, I think, Austria, Austria's, what is Austria's capital? Austria. Okay. Vienna. Vienna-based United Nations UNIDO development report. And I wrote for the United Nations Industrial Development Organization based in Vienna, okay, back in 2005. But growth performance accounting remains the same, as an example. Okay, the summary introduction and introduction to 2 articles I have briefly mentioned. And now it's time to resume chapter 4's, let's say, let's see. Okay, chapter 4. Economic performance, economic development in macroeconomic terms. And we resume by looking at chapter 9, page 19, page 18. Okay, page 19. Okay, this is sources of growth, factors of production. I know Irkutsk State University students, Tomsk State University students, all Russian students are very good at mathematics. This is a very elementary mathematics, but we need to analyze economic performance by using mathematical symbols. Here, QT is denoting gross GDP, real GDP. real gross domestic product. LT is labor input. Capital input is KT. TT is called total factor productivity, or some other economists refer to T as a technical change. We call L, T, and KT are two primary factors. In other words, we can produce goods and services, QT, by using labor input and capital input. So labor input, capital input are fundamental primary factors. This time T, or total technology or total factor productivity symbol, is usually unobservable. We do not have the data for T. So growth accounting is what? We have data for GDP, QT. We have data, LT, employment, labor input. We have data for capital input, KT. But we do not have TT. So identifying total factor productivity by means of three data sets: GDP, QT, LT, labor input, KT, capital input, we define that as growth accounting. Okay, symbolically, we can put this into more meaningful, identifiable production function. This type of production function we usually call Cobb-Douglas production function with neutral technology TT in front. Okay. Here, typically, alpha is a share of labor income in total income. In other words, QT generates real GDP, generates total income. Total income, gross national income, should be exhausted, should be distributed out to labor and capital. So labor's share alpha, capital's share beta should usually add up to 1. In other words, alpha plus beta is required to be 1 to have exhausting national income into labor income and capital income. That's it. There shouldn't be any more income other than labor income and capital income. Therefore, alpha plus beta should be equal to 1. If alpha is 0.6, beta must be 0.4. That way, we are forcing this production function to exhibit constant returns to scale. To make this function constant returns to scale, alpha plus beta should be equal to 1. Okay, we can transform this by taking double logarithm, taking logarithm on both sides. Then ln qt, and the first term is ln tt, and that is just written as tt, alpha ln lt plus beta ln kt. You can put this tt ln tt. It should not make any difference. I would use ln tt rather than tt here to be consistent. And you can make use of one of the derivative rule or derivative concept, differentiation concept. If you take a certain logarithm time function of a variable, if we take derivative of logarithm function with respect to time, that gets you this variable's immediate growth rate. In other words, taking log of a certain variable is equivalent to its growth rate calculation. So ln tt's time derivative is t. Alpha remains the same. ln LT's time derivative is growth rate of labor. Beta remains the same. ln KT's growth rate over KT with respect to time, GK. So, in other words, the last equation is the basic form of growth accounting. GDP growth rate should be decomposed. Alpha times labor growth rate plus beta times capital growth rate and the residue of T, technical change growth rate. Okay, of course, here alpha plus beta should be equal to 1. With that restriction in mind, I can rewrite this whole thing. And this is a fundamental growth accounting equation. The variables is explained and listed again at the bottom. Okay, so this is the equation. Then we need to apply that equation to any kind of data set. And this is a textbook derived, textbook given data set. Okay. First, this is the data set for the period of 1963-1973. Really high growth period in the Republic of Korea. After President Park consolidated power in 1962, in 1962, they began first 5-year development plan. So this is up to the second 5-year development plan. After 10 years of Korea's economic miracle began. You see, as later reading required, like by Lucas or by Lucas and Krugman and all these famous economists refer to this period's Korea's growth as miracle. Why is it miracle? Because the whole economy, GDP at factor cost, averaged 9.9% per year based on 1970 constant prices. That is real economy moving at the speed of 10%, every year 10% increase. That's world record. No country on the globe in such a short period, 10-year period, had average 9.9% GDP growth rate. No country has ever done that. So that's why these economists, Krugman and Lucas, called economic miracle, South Korea's economic miracle. Why is it miracle? Okay, we are decomposing. How? Then 9.9% achieved. Roughly speaking, capital increased 6.9%. And the labor employees, if we choose employees as data, 3.8%. I don't know what is the capital share and labor share. This table doesn't show us. So let's take a look at what other tables they gave you. No. You see, they gave you information. Probably this table, I'm going to take this up. I'm going to take out here. It should be here, located here. It is late located in later page. You see table 21. Immediately after table 20 makes sense. Why? Because I explained table 20. How? whole economy output GDP grew 9.9%, capital grew 6.9%, employees labor 3.8%, but I didn't explain how much percentage of capital income, labor income. That information is right here available. Hey, it says GDP at factor cost. If we use A column, capital share of attributable is 39%. Labor share applies 61%. They want us to apply capital share alpha 0.39, beta 0.61. Together should add up to 100%. Okay, so how did I calculate these, combine these information, and show you how to make a growth accounting? Okay, I'm going to go through growth accounting, whole economy. At home, when you go home, please take care of mining and manufacturing. You take care of mining and manufacturing growth accounting at home. Okay? And I will take care of whole economy growth accounting explain. So in other words, you imitate what I do for the whole economy. And when you go home today, you try to interpret mining and manufacturing sector growth accounting. Okay, whole economy first. How did I make growth accounting? Output, GDP, good 9.9%. Here is 9.9%. Capital, 6.9%. All including land, we use this capital concept, 6.9%. What was the share of capital share? 0.39. Who told you? Nobody told me, but I quoted this table 21, first row. 39% capital share, 61% labor share. So I moved that here. 39% capital share, 61% labor share. So 0.39 is like alpha. 0.61 is like beta in terms of notation. Okay, 9.9% is sitting here. And whatever you combine these two together, there will be something left over. That something is total factor productivity or technical change. TFP, total factor productivity, is 4.891%. Capital growth rate times capital share, 2.691%. Labor growth rate, 3.8% times 0.61, 2.31.8%. So when you have done this complete growth accounting, the last step is to take care of share of growth attributable to, or we call relative share of each input. So in 9.9%, capital occupies 2.691%. Labor occupies 2.318%. TFP occupies 4.891%. Or I can explain 9.9% GDP growth rate is decomposed into three parts. Capital contribution, 2.691%. Labor contribution, 2.318%. TFP, 4.891%. So this decomposition can naturally lead us to estimate relative contribution. Capital contributed how much to GDP growth rate? By how much? So this relative contribution can be calculated 2.691% by deflating 9.9%. In other words, in explaining GDP growth rate 9.9%, capital contributed 2.691%. That is, relatively speaking, capital contributed to 27%. Relative contribution. Labor, the same way, occupies relative contribution 23%. TFP, the remainder 50%. Of course, these three numbers, 27%, 23%, 50%, should add up to 100%. Okay, the rest, I'm intentionally not going to explain. I will give you this as an exercise at home. Please go through this row at all. Bottom, growth accounting, mining, and manufacturing. Find out where the numbers are quoted from. Probably from here and from here. Table 20, table 21 are the sources of all the numbers here. Okay. Now, let me give you another exercise. Another exercise is output GDP at factor cost, mining and manufacturing. 18.4%. We just saw economy-wide 9.9%. If it is 18.4%, is economy while economy-wide is moving 9.9%, another sector, mining and manufacturing, moves at double the speed, 18.4%, moves even faster. In other words, mining and manufacturing was taking a sports car, while average average economy-wide output growth rate was taking a bus. Mining and manufacturing was taking a sports car ride. Utilized capital, labor, and so forth. All this information, where did it come from? Okay, let's take a look at it. Here, mining and manufacturing, table 21. Table 20 is mining and manufacturing. If you look at table 20, back, mining and manufacturing is right-hand side corner column. GDP at factor cost was indeed 18.4%. Here is reproducible capital is something reproducible capital without land. Land is not reproducible. Land is fixed capital. So reproducible capital is except land. That 11.0%. But they seem to have used, rather than reproducible capital concept, utilized capital. What is utilized capital? Suppose reproducible capital is some kind of factory. The economy cannot use 100% of the factory. Some factory equipments can be idle, can be under repair, and so forth. So utilized capital is kind of utilized capital out of reproducible capital. So utilized capital is more effective capital. The capital which was put into production activity. So I think this growth accounting calculates this last growth accounting. Growth accounting, mining and manufacturing, output 18.4%, utilized capital 19.8%. Labor, let us take a look at labor statistics. Here, right-hand side and the column, if you look at mining and manufacturing, there is the composition of employees, is number of people. When we transform into hours worked, human capital per worker, and in other words, employees one category of labor, but that can be more in detail decomposed into hours worked, human capital per worker. Okay. So hours worked is 10.7% increase. Human capital per worker is 2.2%. Okay, now I think for this particular exercise, you see, they added 10.7% to 2.2%. And the capital share applied 0.75, labor share applied 0.25. Where did they get it? Okay, here, mining and manufacturing, table 21. They ask us to apply capital labor shares applied 75%, 25%. So we quote that here, and 75% here, 25% here. Total GDP growth rate 18.4%. Therefore, the residual T is grown 0.325%. Okay. Here, I need to explain why you can add hours worked to human capital per worker. Okay. That needs some kind of a little bit mathematical explanation. So what I would like to do, labor input, okay, can be identified as labor input, L as input, hours worked, number of hours worked, times quality of it. So for example, suppose number of people, now number of hours worked was 100, but quality was on the average. So quality index 1.0. Then L becomes 100. Suppose N is 100 hours, but quality upgrade 1.2. Quality index 20% above increase than last year. Then 100 times 1.2, L becomes 120. Okay, so if you take log of L, that is becoming ln N, and log applying becomes additive form, ln Q. Okay, therefore, growth rate of L, growth rate of L should be equal to growth rate of L N plus growth rate of two. That's why here I added 10.7% growth rate of working hours plus quality index increase, human capital per worker increase 2.2%. Together becomes labor contribution, of which relative income share was applied 0.25. Okay, so here 내가 언제까지 강의를 해야 되냐? 6시 아직 30분 남았지? Okay. So what I'm trying to explain, I want to compare this result. What result? Mining and manufacturing, specific part. This result and relative contribution calculation, again, as an exercise. Capital with income share multiplied 14.85% contribution. Labor contribution after combining 10.7, quantity increase, quality increase 2.2%, multiplied by labor share 3.25%. Out of 18.4%, we took residual T, that is occupied to be 0.325, relatively very little. So how do we calculate relative contribution? Relative contribution of what? Capital contributes relatively how much to 18.4% GDP growth? Labor, how much? Total factor productivity, how much? This how much should add up to 100%. So first, capital in manufacturing sector occupies 81% of 18.4% GDP growth. When we say GDP growth is 100%, 81% is explained by capital in manufacturing sector. 18% by labor, TFP by only 1%. Okay, so I want you to compare this result, page 25 result, with what result? Economy-wide, table 21, this middle result. I want you to compare this result with this growth accounting result. Okay. I want you to compare this result with this result. So blue one with red marked one. Red marked one. Blue one with this red marked one. Okay. So this red marked one is entire economy. What was the relative contribution analysis? Well, we found out of GDP growth rate of entire economy, whole economy, 9.9%, capital contributed 27%. Labor contributed 23%. Bulk of them, 50% were occupied by technical progress. Very strikingly different result. Where did you find the different result here? Manufacturing sector. Okay, you found in manufacturing only, your relative contribution analysis shows capital occupied 81%. Labor occupied relatively small percent, 18%. TFP, almost nothing. So how do you interpret this? Okay. In case of Korean economy, manufacturing only sector, manufacturing only was so dominant by capital contribution. In other words, massive POSCO, Pohang Steel Company, Hyundai Automobile Company, 80% of all those manufacturing facilities, shipbuilding, industry, all occupied by capital contribution, capital dominant. Labor followed, but 18% only. So there was almost no increase in TFP. We call this process capital-led growth. No efficiency growth led. So almost zero efficiency growth led. Capital dominant growth process, capital-led growth was Korea's manufacturing industry from 1963 to 1973. Strikingly different is the entire economy. Entire economy, of course, based on their data, entire economy grew 9.9% speed GDP, but capital contribution explains only 27%. Labor, about 23%. The rest, dominant explanation, was technical change. What does that mean? Well, while mining and manufacturing sector in Korea was capital dominant, agricultural sector and service sector, it was more technology. Technology dominating growth was done in service and agricultural sector. Therefore, economy-wide total shows somewhat balanced growth contribution, capital roughly 27% contribution, labor contribution 23%, dominant contribution by TFP for the entire economy, which is strikingly different from manufacturing growth experience. Okay. Now, we cannot do anything better without using growth accounting technique. So my midterm exam, final exam, all will ask you about growth accounting result. And I will give you an example. So doubled capacity utilization for manufacturing, increased share of individual sector over growth. By 1974, by 1976, export earnings exceeded import expenditure. This is a very important event because before that, prior to that, 1974, 1976, Korean economy always export was less than import. Ultimately, this goes to budget foreign trade balance deficit. Therefore, this goes to foreign exchange shortage. Foreign exchange means dollar. You have to import $100 billion worth, but your export earning is only $80 billion. Then trade balance deficit is $20 billion minus. Therefore, you are always in short of dollars because your earnings from export is less than your expenditure in import. But this changed from 1976 on. Export earnings started exceeding import expenditure. Okay, this is turning point. And over. The turning point. Yes. Foreign trade. Commitment for domestic resource utilization. Before the first 5-year plan, 10% of GNP is domestic investment. But in 1974, 1976, 27% of GNP became 27% of GNP became domestic investment. So that much portion of GNP, gross national product, was going into domestic investment. It used to be 10% range at the beginning of first 5-year plan, so around 1962. But it became 27%. Okay. Korea's real average GNP growth rate, 7.85% since 1953, and since 1960 jumped to 9.6%. World Bank records Korea's per capita GNP growth rate, 7.3% during 1960-1973. Only Singapore, Hong Kong, and Taiwan had the matching growth records of Korea. We ultimately called these the 4 tigers. Korea's pattern of accumulation, saving and investment, and allocation, primary and industry shares of output, export and import, and so forth, can be compared with Chenery and Sirkin's analysis, 100-country case from 1950 to 1970s, normal developing economy. Korea's performed poorly during 1953-1962, before President Park's regime appeared. During Lee regime, Korea performed poorly, less than Chenery and Sirkin's norm. That is 101 countries average, Korea always below average. But started exceeding the expected norms norms means 100 countries average. By early 1970s, Korea exceeded average country in channel and sequence analysis. Okay, so Korea's basic change from an inward-looking import substitution to outward-looking export promotion became remarkable growth and structural change. I explained Korea had to take import substitution inward-looking policy in the 1950s because Korea had no choice except taking import substitution inward-looking policy because Korea was so low in export earnings. There were almost no products exportable. Almost no products exportable. Therefore, Korea had to take inward-looking policy, save on foreign exchange, try to substitute sugar making by domestically produced sugars, and a lot of hygiene products, domestically substituted hygiene products, but ultimately toward outward-looking export promotion in the 1970s. To 1970. Remarkable growth and structural change follow. Will the export-oriented growth continue in the future? Will you remember Mason et al. Book is 1980. So at the time of 1980, they were contemplating Korea's export-oriented growth will continue in the future, meaning that after 1980s, 90s, 20s, 2010s, 2020s, they were questioning inflation, the weak point, was stabilized at 10% by 1976 and below 3% since 2000. Government preference for growth rather than stability. Always Korean government wanted to make growth rather than price stability. Okay. This is Korean development compared with channel circuit regression means is kind of subsidiary explanation, but I might want to spend taking a look at this. Okay. Here, the way you look at the table, Korea parameters here, and 1953, 1955 average, 1960, 1962, at the beginning of Korea's 5-year development plan, 1972, 1974, after 10 years of Korean development. So this last end, first end, we can compare, for example, predicted by large country pattern, and for example, comparison share of GDP, large country patterns, 1953, 1955 average, savings rate 4.3%. But Korea's actual savings rate is less than 2%. So that much Korea is below average. Investment 11.3%, Korea. Average developing countries occupied 14.2%, and so forth. For example, exports, Korea actual export was 1.5%, average developing countries 7.2%. So way below Korea's average was located. But by 1972, by 1974, Korea's GDP, actual GDP was 175.4, and savings rate exceeded 22.8% from 16.5% large country average. Chenery and Sirkins pooled 100 developing country nations. Savings rate average was only 16.5%. Investment, Korea achieved 25.8% of GDP. Average countries, 20%. How about exports? Exports, Korea occupied 26% of GDP. On the other hand, large country pattern, 10.7%. Okay, so that much, there was a big transformation from 1950s to 1970s. Korea's average performance exceeded Chenery and Sirkin's average developing countries by far, by very large margin. Okay. So we have finished it. I might want to stop for today up to this presentation and maybe listen to your questions if you have any questions. Okay, I will open the floor for your questions. Mikhail Solovyov, do you have any question? Daniel Smigidin, TSU, do you have any questions?
Thank you, Professor, for your lecture, but I'm sorry, I don't have any question.
Okay. Are you ready for reading summary? Are you looking at the article now for reading summary, Daniel?
Unfortunately, Professor, I'm not ready yet.
Oh, but you can have more time and you can submit later, okay? I gave you, I think, 2 weeks duration for submitting summary, okay?
Okay.
Yeah. How about Paulina? Paulina Nekaeva, are you there? ISU?
Yes, I don't have questions. I understand.
Okay. Are you ready for reading summary?
Not yet. Sorry, but not yet.
You will get it right soon. Okay. How about Valeria Trujillo?
I don't have questions. Thank you.
Are you ready for reading summary, Valeria?
A little bit.
Yeah, okay. You have time, right? You have 2 weeks time to prepare for summary. So please
Yes.
take time. Okay, how about Shvetsik Dmitry, ISU? Dmitry, are you there? Okay, I thank you for all of you attending the class and paying attention to somewhat difficult subject. Today we reviewed growth accounting. I think it's technically most difficult part of entire my lecture, but inevitably this is a must. Without knowing growth accounting, you cannot read any further articles. Articles by Lucas, articles by Krugman, and articles by myself, and articles by Young. All these economists' contribution are concentrated into growth accounting and its interpretation. So please be ready for growth accounting. Review what we have done today very carefully, and your extra readings will help you understanding growth accounting. Thank you for all of your attention. Thanks.